So let's take a look at this set of polynomials, 1, 1 minus t, and then 2 minus 4t plus t squared. We're going to note that this is we want to show that b is a basis for p2. That is, every polynomial of degree 2 can be written as a unique linear combination of these three polynomials. And then we want to find the coordinates of p relative to this basis. So show that b is basis for p2 and find the coordinates of p relative to b. Now, we can solve this problem as a polynomial problem because we want to figure out how much of this first vector, so I want to say, let's say c1 times this first vector plus c2 times the second vector plus c3 times this third vector how is that going to equal 5 plus 5t minus 2t squared? So this is what we're talking about if we're just going to limit ourselves to be living in the land of polynomials. This is what we're trying to find, c1, c2, and c3. That'll be how we write 5, 5, negative 2 as a combination of 1, 1, negative 1, 2, negative 4, 1. But we want to do this in a linear algebra way, because P2 is really just a version of R3. So we're going to apply a coordinate map to this entire problem. So we're going to apply a coordinate map from P2 to R3. We're going to apply a coordinate map from P2 to R3. So my basis as coordinates will look like 1, 0, 0, and then 1, negative 1, 0, and then 2, negative 4, 1. And my polynomial p will be 5, 5, negative 2. So now, instead of writing all this out with all these polynomials running around, I'm just going to look at all these things as vectors using the standard basis for P2. Oops. Then if I want to write P as a linear combination of B1, B2, and B3, I just have to throw it all into an augmented matrix and find its reduced echelon form. So let's do that. I'm going to have 1, 1, 2, 5, 0, negative 1, negative 4, 5, 0, 0, 1, negative 2. I didn't check. Let's see. 1, 1, 2, 5, 0, negative 1, negative 4, 5, 0, 0, 1, negative 2. So there's my augmented matrix, the reduced echelon form. So we can see that the first three columns do in fact form a basis for R3. And so the vectors in B must be a basis for P2. Then the last column tells me how to write P relative, how to write the coordinates of P relative to that basis. So this says that C1 is equal to 6, C2 is equal to 3, and C3 is equal to negative 2. So that the coordinates of P relative to B, since these are coordinates, they will look like R3, but it'll be 6, 3, negative 2. Just make things look like Rn. That's all we need to do. Make things look like Rn. So if I take this linear combination of the three polynomials, if I calculate 6 times 1 plus 3 times 1 minus t minus 2 times 2 minus 4t plus t squared, we get 6 and 3 is 9, minus 4 is 5. Let's see, no t's here. So minus 3t, minus 3t plus 8t is 5t, and minus 2t squared. Everything checks out. Any questions? How's everybody, okay? All right. So this is what we are on about. What I want you to do this week is look at all the problems or all the homeworks from chapter 4. So get as far as you can on 4.1. If there are some that you don't understand, you do not get to let that stop you from moving on to 4.2. You go on to 4.2, you do as many problems as you can. You do not let that stop you from moving on to 4.3. Do as many problems as you can and continue on all the way through and find out what you're stuck on. If you're doing problems from 4.1 and you get stuck and say, I'm not doing anything else from chapter 4, you're doing this wrong and you're just trying to give yourself an excuse to not do any more work. I don't want to do any more work either, but that's not a valid reason to stop. That makes sense? This is the faulty thinking that goes with all kinds of prerequisite stuff. We stop people from doing one class because they haven't had all the prerequisites. So it's like, oh, it's been so long since they took algebra. Put them in the trig class anyway. And then any algebra that we're getting hung up on, we can fix if they've been in an algebra class before. If they've been in a trig class, I don't care how long it's been, they've done some trig, put them in the pre-calc class. I guess my point is put the students in the class that they want to take. Now, if they're like, oh, I want to take Calc 3, but they've never had any calculus classes, that's not okay. But if they took calc in high school, sure, what the heck? Let's see what happens. Any questions? And then switch them back to a previous class if it becomes a problem. And then train your teachers to be able to identify when that problem is. And then make sure those teachers aren't using some stupid test to make that determination. Because tests don't tell how much you know, tests tell you how good you are at taking tests. That's all. It's a dumb skill to have. Any questions? Comments? Snide remarks? So the question did come up, what homeworks will we do this week? Chapter 4. So 4.1, 4.2, 3, 4, 5, 6, 7. I think I stopped at 7. Those 7 assignments. Work on those this week. And then we'll talk about some of these problems on, let's say, Wednesday, because that's our next meeting. You'll also have the discussion forums where you can post questions that you get stuck on, and someone might be able to help you. So that's where we're at. You're also the first part of this week, you're working on the quizzes from chapter 2. So make sure you get those turned in because quizzes from chapter 4 are going to start showing up. Any questions before we stop recording? No, 4.x is its own assignment because all those problems are connected together. So those all go together. So 4.x should be its own assignment. Chapter 3 we're supposed to do, but I'm not going to be covering I'm not going to be going over any questions. You can post in the discussion forum on the problems from chapter 3. It's about determinants, and determinants is always something that we can pick up later. All the things that we do with determinants are better done doing something else, with very few exceptions. So that's all. It's kind of like people saying, oh, they shouldn't switch the Mustang from a live axle because live axle is good for drag racing. most of the time, Mustangs aren't drag racing. They're just crashing at cars and coffee into people. So that's like the one thing that a live rear axle is going to be good at, of all the things that we ask our cars to do. So that's a dumb reason to keep it. Like, for those of you who are going to look at chapter 3, there's a thing called Cramer's rule. That is like the dumbest way to solve a system of equations there is. It's neat and it's cool, and I'm glad Cramer found it, or I'm glad Cramer thought it was cool enough to name it after himself, because anything named after someone, most certainly that person did not discover a thing. But if you're like, oh, I need to solve a system of equations, I'll use Cramer's rule. That's when you just start getting slapped. It's like, oh, come on, man. Now you've got to come, if it's 3x3 system, you got to find 4 determinants and then do calculations on top of that, like division, so it's not a big deal. But come on, man. There's a better way to solve systems of equations. Have a computer do it. And if you're saying, well, I'll just have the computer do the determinants, then you're going to get smacked for tying up all that computer time on these stupid determinants when you could have been done hours ago. Because just because the problems that we normally encounter can be done quickly by computers, it doesn't scale well. Cramer's rule doesn't scale well. Finding the inverse of a matrix doesn't scale well. It's fine to grab our calculator and find the inverse of a 3x3 matrix. It'll do it quickly. But what if our matrix is 600 by 600? Now Texas Instruments is like, oh no, I can't handle that. That's too much. And all of a sudden we start dealing with too much computer power is required for the thing. Yeah, I don't know. Removing Cramer's rule from national math standards is not a thing because there are no national math standards. National math standards aren't a thing. There's an attempt, there's kind of attempt to make national math standards like the Common Core, but it's kind of, all Common Core, it's not an imposition. Common Core is just like, oh, hey, here are the things that you're pretty much doing anyway. And so why don't we all do these things? And then people are like all freaking out about it. If you want to object to Common Core, I'm totally for it, because Common Core, the way it's designed, is to get people to pass tests. Anytime we're imposing tests on children, we are making a huge mistake. That's my problem with Common Core. But all these parents that are complaining about how Common Core, they don't know how to do the work in Common Core, so it should be done somewhere else. It's like, well, you ain't the teacher. Just stop. Just because you don't know how to do your kid's homework, just don't help your kid with their homework. Say, sorry, Johnny, you're gonna have to do this on your own. Because that'll be a better experience for the kid anyway. All these parents that are complaining about Common Core and crying because they're too dumb to do the problems, because they and say, oh, this isn't what we were taught. I assure you, they were taught that. They just don't remember. And they need to just get out of the way, let the kids struggle. Anyway, that's my rule. Let the kids struggle. Even if you know how to do your kids' homework, get out the way. Let the kids struggle. Anyway, let me pause the video here.